let me introduce you to one of my robots. Teaching robotics to Year 13 students has been a lot of fun over the years. We've made quite a few things. So this was one of the ones that I made as an example of what you might do. This is the rat. So quite a simple idea. The wheels are run off two motors in this gearbox. You can configure the gears with different ratios, different combinations of gears to get different ratios. Then I put these, I guess you would call them bumps on the wheels, different height bumps to give it some sort of lurching kind of motion. And then there are a couple of servos. There's one to waggle the tail and another one to move the head. So this is all controlled using a circuit with a pickaxe microcontroller, which is what I was teaching. Get that out of there. And most of the construction is aluminium cable ties. This is a piece of thermoplastic, so vacuum formed, painted on the inside with a kind of a chrome paint. Same as the head piece here, and then this is aluminium. There's some hot glue to create some grip on these bumps on the wheels. Got a battery pack inside here. This is what's called a Kiwi patch circuit board for prototyping, and you've got all kinds of things going on inside here. Transistors and resistors. The chip, it's hard to see in amongst all that tangle of wires. It's a 14-pin pickaxe chip down in here called a 14M2. You've got some light dependent resistors up here and another one in the nose, and then these LEDs will send out a signal, an infrared signal to other robots. You've got a touch switch on the back, we call that, as a sensor as well. So that's what it looks like on the inside. There's also a little sort of speaker down here that you can make noises with, so it can make some scratchy noises with it. Switch to turn it on is just on the battery pack under here. So we turn it on. So that's the first thing it does, just to tell us that it's working. Then it's got these three sensors. If I cover up the nose sensor, it will waggle the tail. If I cover up the sensor on this side, it will turn away from my finger or my thumb or whatever I'm covering it with, and the opposite side. So those are like ears. You can see up here that we've got transistors down here with an LED, just to show that that is active, which is really helpful when you're building the circuit before you have motors working, is to see whether the circuit is actually activated. So that's what the purpose of that was. Now in the front here you have an infrared receiver. So the idea is this could receive signals from other robots that are sending signals out of these infrared LEDs, so another robot, and so it could respond to that other robot. So we had lots of robots that were interacting with each other that would be built by the students. So what I've used the switch for on the top here is to put this into a mode where it will now respond to infrared signals, which in this case we will just use this kind of remote control here. So this has 4 input switches which will send out different signals out of these infrared LEDs up here. So these senders here will send an infrared signal, and each one will have a different code attached to it. So this allows us to drive the robot around. So one of these just makes both motors go, so it's driving forward. Another of the signals will make the robot try to turn left anyway. It's possibly not grippy enough surface for it, while also kind of sniffing in that direction. And then we've got the opposite one of those. And then lastly we can wag the tail. So you can drive this around with the remote, or you can have it so that it's responding to signals coming out of another robot.